The job description of chemical engineer is a rich and multifaceted role that lies at the intersection of science, technology, and industry. Chemical engineers apply their expertise in chemistry, physics, biology, and mathematics to solve problems related to the production, transformation, and use of chemicals and materials. From designing and optimizing industrial processes to developing new products and ensuring their safety, a chemical engineer plays a key role in numerous sectors, including pharmaceuticals, energy, food processing, cosmetics, and materials manufacturing. Chemical engineers are innovators and problem solvers. They translate laboratory discoveries into large-scale production, designing equipment and processes that maximize efficiency, minimize waste, and control costs while complying with health, safety, and environmental regulations. Whether it's designing a new pharmaceutical production process, developing a more energy-efficient way to produce fertilizer, or creating a renewable material, chemical engineers help bring innovations from concept to reality. Primary responsibilities of chemical engineer. The job description of chemical engineer typically starts with designing and developing processes for the production of chemicals and related products. Chemical engineers apply their knowledge of reaction kinetics, thermodynamics, and transport phenomenon to create processes that are scalable, cost-effective, and environmentally friendly. They perform extensive calculations, develop flowcharts and process simulations, and select appropriate equipment to match production goals. Once a process is designed, the chemical engineer oversees its implementation. They may work closely with plant engineers and operations crews to construct and start up a new production unit. During this phase, the chemical engineer must troubleshoot problems, fine-tune conditions, and make sure everything operates safely and efficiently. Another key responsibility involves optimizing existing production processes. The chemical engineer investigates bottlenecks, inefficiencies, and waste points in a process and develops modifications or improvements to raise output, cut energy usage, reduce emissions, or enhance product purity. Continuous improvement is a large part of a chemical engineer's role in many industries. Furthermore, a chemical engineer must perform rigorous safety and environmental reviews to minimize the risk of accidents and to control emissions and waste. They may employ techniques such as hazard and operability studies, HAZOPS, process flow analysis, and simulation software to anticipate and resolve potential problems. Support and communication. Effective communication is a central aspect of a chemical engineer's responsibilities. They frequently collaborate with multidisciplinary teams, including mechanical engineers, industrial engineers, chemists, and production supervisors, to implement and improve production processes. Communication skills are also essential when explaining complex technical information to non-engineers, stakeholders, or regulators. Chemical engineers may be required to prepare reports, charts, and graphs to convey their findings and recommendations. They typically present these results to supervisors, production managers, and executive teams to help them make informed decisions about process modifications, capital expenditures, or health and safety measures. Furthermore, a chemical engineer must be able to work alongside regulators and health and safety inspectors to assure compliance with applicable codes and standards. They may produce documentation for environmental reports, permit applications, and hazard analyses. Essential skills and qualities for the role. To be a successful chemical engineer, a person must blend a strong technical background with interpersonal and problem-solving skills. Naturally, a deep understanding of physical and organic chemistry, thermodynamics, mass and energy balance, and reaction kinetics is a prerequisite. Furthermore, a proficient chemical engineer must be able to perform complex calculations, create mathematical models, and employ specialized software to aid in designing and optimizing processes. Excellent problem-solving skills are a must. A chemical engineer frequently finds himself or herself challenged by production bottlenecks, reaction inefficiencies, or equipment malfunctions. The ability to quickly identify, troubleshoot, and resolve these issues is a key attribute for success in this field. Additionally, communication skills, both oral and written, are extremely important. Chemical engineers need to convey technical information to a range of stakeholders, from plant supervisors to regulators, and collaborate effectively in a team. They must be able to translate specialized knowledge into clear, actionable plans and instructions. Project management skills, a keen eye for detail, and strong organizational ability are also desirable. Chemical engineers often handle multiple responsibilities and must be able to prioritize tasks and resources efficiently. Furthermore, adaptability and creativity are valuable traits. A process may perform differently under certain conditions, or a production bottleneck may arise unexpectedly. A successful chemical engineer must be able to respond quickly and innovate on the spot. Work environment and daily activities. Chemical engineers typically work in industrial settings, research and development laboratories, or corporate offices. A large portion of their time may be spent on site, at a production plant, where they can directly observe operations, troubleshoot problems, and implement modifications. Some days may be filled with designing and developing a process flow diagram on a computer, employing specialized software to perform mass and energy balance calculations. Other days may be devoted to meetings with engineers from other disciplines, production supervisors, or health and safety officers to resolve issues or implement a process improvement. Chemical engineers often split their time between the office and the plant. They may need to wear protective equipment, hard hat, gloves, goggles, when entering processing areas. Furthermore, travel may be required, particularly if the engineer is responsible for facilities in multiple locations or for designing a process at a site under construction. Training and educational requirements. Most chemical engineers hold at least a bachelor's degree in chemical engineering. Some pursue a master's or PhD to specialize in a particular area, such as biotechnology, materials science, or petroleum processing. An education in this discipline typically covers a range of subjects, from advanced mathematics and physical sciences to specialized chemical process design and control, to produce graduates who are proficient in both theory and practice. Some roles may require a professional engineer (PE) license, which involves passing exams and having a minimum amount of work experience under a licensed engineer. Furthermore, certifications in specialized software or process safety may be desirable, depending on the industry and responsibilities. Continuous education is often necessary to stay up to date with innovations in technology, industry standards, and environmental regulations. Chemical engineers may pursue short courses, certifications, or advanced degrees to broaden their knowledge and stay competitive in their field. Conclusion. The job description of chemical engineer underscores a role that is at once challenging, versatile, and profoundly rewarding. Chemical engineers apply their knowledge of science, math, and technology to solve real-world problems and develop products and processes that shape nearly every industry. From designing large-scale production facilities to optimizing energy usage and reducing waste, their work directly impacts the way we produce food, pharmaceuticals, materials, and energy. This role demands a unique combination of technical expertise, problem-solving ability, communication skills, and adaptability. Chemical engineers must be able to navigate complexity, innovate under pressure, and collaborate across disciplines, all while honoring health, safety, and environmental responsibilities. Successful chemical engineers find deep satisfaction in seeing their designs come to life and contribute to the well-being of society at large.